So, good afternoon to all. So, in the last class, we have discussed about how the MapReduce are working. Okay. So, today we will see that what are the different other techniques are there which will be used to process large quantities of data. So, which is similar to the MapReduce, which will make use of the MapReduce technique. Okay. The first one. So, when you talk about the MapReduce technique, so what is the MapReduce technique? So, it is nothing but a simplified model. So for what purpose it is going to be used? It is going to be used to process large quantities of data. Okay. So now when you are processing a large quantities of data, so what you are going to make use of? So it is going to make use of the distributed algorithms, and it will be running over all MapReduce infrastructure. So if you tell about the MapReduce infrastructure is nothing but what? So it is going to have the distributed systems nodes are there. Among the distributed nodes, this particular distributed algorithms are going to work, and depending upon the requirement, that particular data will be retrieved from the database, which is located all over the world. So distributed is nothing but what? So all the systems are linked together, and it will be treated as one whole system, right? So that is what the basic definition of your distributed system. Now, when you are going to have, so there are some series of extension variations which are being used to the original MapReduce models. So it will be working same as the MapReduce model. So some of the collection of MapReduce framework is originally defined from the original MapReduce model. So what are those? Are some of them are like Hadoop is there, Pig is there. So if you go with that one, so some of the variations which you are going to have is, so you are going to have the Hadoop. Okay, so Hadoop is one version. Pig is there, so that is another version which will be making use of your MapReduce model. So third is Hive. Hive is there. So fourth one is MapReduce merge is there. MapReduce merge is the fourth one, and the last one which you are going to have is a twister. Now, so if you have seen your requirements, so in your ad like that on, so in most of the places they are going to make use of the Hadoop Pig and Hive. Okay, they will ask you the requirements which you require is for Hadoop Pig and Hive. So if you learn this one, so you can have a lot of opportunity in the market. Okay, so if you are interested towards the cloud and big data, so if you're talking about the big data also, so you have to make use of the MapReduce. That is the main concept which you are going to use to analyze the data is your MapReduce model only there also. So the some of the variations and extensions which you are going to have in your MapReduce model are these five. That is your Hadoop, Pig, Hive, MapReduce merge, and twister. Now let us come to the Hadoop. So what is a Hadoop? So your Apache is the creator of that particular Hadoop. So this particular Apache Hadoop is nothing but what? So it is nothing but the collection of softwares. Okay. So it is nothing but the collection of softwares which are going to have. It's a collection of software projects for reliable, scalable, distributed computing. So it is mainly used for reliable and scalable distributed collection. So if you talk about the Hadoop, okay, so the entire collection which you are going to have in your Hadoop implementation, so it is an open source implementation. So its entire collection is of open source implementation. That means what? You can have all your codes in the net freely. You can use that one, and you can work on that one. Okay, so this particular Hadoop is an entire collection is an open source implementation of what? So of the MapReduce framework. Okay, so it is going to be have the open source framework which is going to make use of your MapReduce framework. In that particular MapReduce framework, what it is going to use? So it is going to make use of the GFS, that is Google file system, supported by the Google file system like distributed file system. So already we have discussed about your Google file system. So here it is basically supported by the Google file system. So your Google file system is nothing but the distributed file system. So now what made this particular extension to be created is the next. So this particular extensions which you are going to have. So this is basically an initiative consists of two projects. Okay, so this particular it is nothing but is a collection of open source implementation, and it is basically consists of mostly two projects. What are these two projects? One is Hadoop distributed file system is one project which you are going to have. Other is your Hadoop MapReduce. So the MapReduce technique which we have already discussed. So that is one of the project which will give the inspiration to build your Hadoop framework. Okay, so when you are going with the former, okay, so the later when you are going to have SDFS, that is nothing but your Hadoop distributed file system. So now this is basically the implementation of the Google file system. That means your Hadoop file system is basically replication of the Google file system. Whatever how the Google file system is going to work, so the same way your Hadoop file system is going to work. So now to build this particular Hadoop file system, what they do, so they had some of the features. Okay, so they took some of the ideas from the Google MapReduce. So that is nothing but the abstraction. That is ideas which have been implemented in your Google MapReduce. They are going to take that particular ideas, and after taking that particular idea from the Hadoop, so they are going to implement it. So they are going to implement it on your Hadoop distributed file system. So basically, this particular Hadoop is developed and supported by Yahoo. Okay. So in the beginning, it was developed by Yahoo. So now, how the app is constitutes of, so it is going to have the Hadoop considers now the most major, mature, and large data cloud applications. Okay. So as we have seen, we don't know that how it is implemented at the backend. So, but in theoretical point of view, we consider that most mature and large data cloud applications are going to be used using this particular technology. Now, if we take about the Yahoo, okay, so Yahoo, most of all, it is going to run the most largest cluster. Okay, so largest Hadoop cluster it is going to build. Since it is developed, your Hadoop is built by the Yahoo. So your Yahoo is going to have the world's largest Hadoop cluster. So if we talk about the cluster is nothing but the group of computers which will be combinedly acting together as a one. So when you have the Yahoo as its own cluster, so Yahoo runs now the world's largest Hadoop cluster. So what it consists of? So if you have the Hadoop largest Hadoop cluster, it is mainly consists of 40,000 machines. Okay, so it's basically consists of 40,000 machines, out of those 40,000 machines, it is having more than 300,000 crores of cores. So 300,000 crores will be there. It is approximately what? So if we talk about the 300,000 crores, is nothing but 3 lakh crores. Okay, so your Yahoo is having the Hadoop largest cluster. That cluster composed of 40,000 machines. Out of these 44,000 machines, you are going to have 3 lakh crores. So average, how much you are going to have? Average, you are going to have 8 to 10 cores in each machine. So you are going to have a system like octa core is there now, dual core is there, quad core is there, right? So that means what? In a single system, you are going to have 2 cores in the dual core. You are going to have the 2 cores in the system. If you have a quad core, you are going to have 4 cores in the system. Now you are going to have the octa core, right? So in the octa core, what will happen? In a single system, you are going to have 5 different CPUs, that is functional unit, which will be performing the operation of arithmetic and logic unit. So this particular core is available for your Hadoop cluster. That is about 3 lakh cores. Okay. So now all these cores, where they are available, these are basically available across most of the academic institutions. So it is going to be make use of the made available in most of the academic institutions all over the world. So you can see it here. So it is made available for all academic institutions all over the world. So now, besides the core projects of Hadoop, okay, so we are going to have most of the institutions in the Hadoop. So there is a collection of other products also. Okay, so which is going to make use of the distributed computing. Okay, so that is how the Hadoop is built. So this is a basic overview of the Hadoop. So we are not gone in depth about the Hadoop. So if you want to have the in depth of the Hadoop, maybe in the next semester you are going to read in big data. Okay, so you have the subject called big data in your next semester. So there you are going to deal completely with respect to the Hadoop as one part. Okay, so there you are going to understand everything. So then it will be easy for you to understand there. Okay, so the next variations in your MapReduce is your, so if you take the MapReduce, so next is your pig. So if you take the MapReduce, it's as I told you in the beginning only. So it basically constitutes a large processing. It is going to be mainly used for the processing the large quantities of data. So now, so it's going to have the constraint. What is the constraint it is going to have? So it is going to have the constraint that how the distributed algorithm should be organized. Okay, in order to run over the MapReduce infrastructure. As we have seen that in the MapReduce infrastructure, you are going to have the master node and the worker node. So your master node is going to allocate, schedule the job. So your worker node is going to work with respect to that one. So that is how it is going to have the mapper and the reducer phase. So that we have seen. So if you are going to have the MapReduce, so if you have the MapReduce, so if you have the storage system here, so you're going to have the mapper first. It is going to go through the mapper. The mapper is going to map the functions. So then reducer is going to reduce and sort after doing the shuffling and all. So after doing the shuffling and the process, so it will want to reduce and it is going to calculate and it is going to merge it. Okay. So that is how the MapReduce is going to work. So now in this particular model, so it is going to be applied in different platform scenarios. Okay. So this particular model, what you are going to have, so it can be applied to different platform scenarios. So what are the different platform scenarios we are going to have? So the scenarios is where you want to make an analysis of large quantities of data, where you want to analyze the large quantities of data. So in that particular type of scenario, you are going to make use of that one. So it is going to provide you the abstraction provided by to process data. That means I have the data. So I have the data. So with respect to data, what I have to do, I have to process it. If I want to process it, how to process is the next question. If I want to make analysis on that particular data, I have to process that particular data. So now if I am going to if my data, when I'm processing it, the processing of the data, it may be either it may be a simple or it may be a complex. Okay. So the processing of data, either it may be a simple or it may be a complex. So it may also require the considerable effort. Okay. So it may also require the considerable efforts which has to be there. So effort should be there. So in terms it has to map to what? So this particular how it will be done. So it is going to be done using the MapReduce technique. So it is going to be done using the MapReduce fashion. So that's why this is one of the extensions of your MapReduce model. That is that MapReduce model. This is an extension. So the next is your pig. So the next which we are going to discuss is about the pig. So your pig is also a platform. Okay, so pig is also a platform. So what purpose it is going to be used? So that particular pig platform is going to be used for analysis of large data set. Okay, so it is going to be used for the analysis of large data set. So basically it was developed by Apache project. So if you take about the Apache project, so it is basically, it is going to be developed by as an Apache project. So mainly your pig is used for what purpose? It is mainly used for the analysis purpose. Is mainly used for the analysis purpose. So what it consists of is the next question. So when you are talking about the platform, which is used to analyze of large data set. So and basically it is developed as an Apache product. So what it consists of? So basically it consists of a high level language. Okay. So some high level language it is going to have, either it may be a Java or it may be a C++ or it may be a .NET. So any of the high level language, they are going to take it. So for what purpose they are going to take it? So for the purpose of expressing the data analysis program. Okay. So they are going to express consist of data analysis program. With what they are going to use the data analysis program? They are going to use the data analysis program coupled with infrastructure. Okay. So they are going to coupled with infrastructure for evaluating these programs. That means it depends upon the program also. That is, program in the sense is nothing but what? We are going to have some n number of algorithms. Okay, so the algorithms has to run. So efficiently it has to run. After running efficiently, so after running efficiently, that particular data has to be analyzed and it has to be coupled. Okay, so then it has to be used with the basic infrastructure for evaluation of this particular program. So now what this particular big infrastructure consists of is the next question. Okay, so if you take the big infrastructures, so the infrastructure layer, it consists of basically a compiler. So whenever you are doing the whenever you are going to make use of analysis of the program, we are telling that we are going to develop using the high level language. When you are developing with respect to high level language, I have to convert that particular high level language to machine level language to compute. Okay, So if you want to compute, if you want to convert from high level language to low level language, so obviously you should require the compiler. You should require the compiler. So for that particular reason, your big infrastructure layer consists of what? Your big infrastructure layer consists of the compiler. For high level language, that produces sequence of MapReduce jobs. Okay, so it will be having the compiler for high level language. So what it is going to, that particular compiler is going to produce, that particular compiler which you are going to have, that is going to produce the sequence of MapReduce jobs. So that means it is going to convert from high level language to low level language depending upon the task which are being given, and it is going to reduce the task. There is multiple tasks will be created, or it is called as mapper. So you are going to create the multiple process. After dividing into multiple process, each process will be allocated to each mapper. So now the mapper will calculate all the list out the items which you are searching. Next, after searching that particular item in the reduce phase, what will happen? So the shuffling is going to happen, and at the reduce phase, the shuffling is going to happen whichever the quantity you are searching in. So that will be moved to one reduce function, right? So that we have discussed. In the same way, it will happen here. So the sequence of MapReduce jobs. So that will be running on top of the distributed infrastructure. So whatever the sequence of MapReduce job, it will be there. That will be running on top of the distributed infrastructure. So you can see it here. So it is nothing but your distributed infrastructure, similar to your Hadoop. So here also it is going to run on top of the distributed infrastructure only. Okay. So it can here what we can tell. So whenever you are going to write that particular program in high level language, so what the developer can express. So I'm going to run a I have to write that particular program in some language, right? So if, telling that pick, so whatever the program you are going to write, that will be the high level language. So how the programmer, how the developer has to express that particular program. So what operation it has to perform. So your developer can express their data analysis program. Okay, so they are in what language they are going to have. So they are going to express the language, textual language, which is called as Pig Latin. Okay, so if we talk about the high level language which the pig is using is your Pig Latin. So it is Pig Latin is the data analysis program. That is a language which they are going to use to express the data analysis program. Now, whenever you are going to have the big data comes into the picture, obviously we should have some database to be there. Okay, so data we are included. So which is this particular Pig Latin, what it is going to do? It basically exposes a SQL-like interface. That means SQL stands for what? Structured query language. So it's basically it is going to have the SQL. So it stands for structured query language. So that means whatever the data you are going to have here, it is structured. So the data which you are going to have is a structured data. So and it is going to be interfaced, and it is going to be characterized by major expressiveness. So that means it is going to have some data to run at the backend, and it should have a characteristics in such a way that whatever the data you are going to have, that should express what it means. Okay, so what it is going to mean. So that is going to support you the reduce the programming effort and a familiar interface which you are going to have. Okay. So now, so that is with respect to the MapReduce technique. So next, when it comes to the next type of variations of MapReduce is your high. Okay. So what it means? So your Hive is also another Apache initiative. Okay. So here also it is another Apache initiative. So Apache initiative is a company which will mainly deal with the big data. Okay. So it's mainly deal with the big data. Okay. So whenever you are going to have the MapReduce techniques involved, so all these MapReduce will be using in your big data. So it is better to learn Hive, Pig, and Adobe when you are in the free time. So you can read it since it's an open source platform. You can download it and you can work it out. Okay, that you can do it in your free time. Whenever you get a free time, that you can use it for your other enhanced skills which you want to learn as part of your curriculum. Okay. So now if we talk about the Hive, so third one. So it is basically a data warehouse infrastructure. So Hive is nothing but it provides a data warehouse infrastructure. On top of what it is going to provide, on top of the Hadoop MapReduce, it is going to provide. So as the name indicates, it's a data warehouse. What do you mean by data warehouse? So warehouse is nothing but what? Where you are going to keep some data. So warehouse we know. So warehouse is nothing but what? If you take the cloth warehouse, where is that where all the cloths will be kept there. All types of cloths will be there. So here we are telling data warehouse. So data warehouse is nothing but what? All forms of data will be there in that particular place. So either it may be a structured data, or it may be a semi-structured data, or it may be a unstructured data. So it depends what type of data you're going to have. So we are telling that data warehouse. So what type of data, I don't know. Whether it may be a structured data, or it may be unstructured data, or it may be a semi-structured data. So now, when you are going to have this particular type of large data set, which is stored in Hadoop MapReduce files. So MapReduce files will be there. So in that particular MapReduce files, as we have already shown that, so either it may be in block data, or it may be in hierarchical structure, that is stream data, or it may be in object format. So there are three formats where the data can be kept. Okay. So the three formats which are going to have your object can be kept is your first either the data can be kept in some object, or it can be kept in terms of blocks, or block streams and files. Okay. So streams and files we are going to have. So your files is nothing but a hierarchical structure. So that means you're going to have it is nothing but your normal directory view of your system, right? So when you are storing some data, for example, you want to store the information, you have one folder by name of your name X. So under that X, you have so many information. So what are the information you're going to have? So like, for example, if I take, so I have one X file. So I have my contents to be there from my college. That is, I have the data from the college, I have the data from the home, or some other work I have to do. So in the college, if I take, I have many semester, like sem 1, sem 2, sem 3. I have to bifurcate that one. So in the sem 1, I may handling two different subjects. So this is what is this is nothing but a hierarchical view. So this particular way when you are arranging your files is called as hierarchical view. So in that particular way also the data will be kept in your Hive. Okay. So it's basically what it is going to provide. So it basically provides the tools. Okay. It provides the tools for easy data summarization. So it basically provides the data for the data summarization. That means you are going to have the data. I'm going to group some set of data. After grouping the some set of data, so a summary of that particular data I'm going to take. So if you have the summary of the data, for what purpose it will be used? It will be used for analysis purpose. Okay, I have the data. So after having the data, so similarly for your class, so what is the aggregate of your class? So data I have to take, right? So I have to take, if I want to calculate the aggregate of section A, B, C, I want the percentage of each individual student there. Okay. So now I have to take the each individual student's percentage and calculate each individual student's average. Okay. So after calculating each student's average, I have to take the average of all the averages. Then I am going to get the total average. So when they are calculating the passing percentage of the average, I have to take who are the people who have been passed in all subjects. Only those people I have to consider, and that percentage only I have to consider. So these things has to be done effectively. So who has to do that one now? This has to be done using some programs. So I have to write some program, and that particular program will be retrieving the data from that particular fashion. Okay. So after retrieving that particular data in some particular fashion, so it's going to have the data summarization. So it is going to have the ad hoc queries. So now, and it is going to provide you the analysis of the large data set. So if you're going to do the analysis of large data sets, what I am going to tell. So they're going to have the ad hoc queries. Ad hoc queries is what? So one system is not dependent on the other system. So whatever the operation you're going to happen, so that particular operation will not be known to other node. Okay. So that is what the ad hoc refers to. So whenever it is necessary, that particular data you are going to take. So if it is not necessary, that data won't be available. So that means when you talk about the ad hoc queries, so as and when required, what you can tell is this as and when it is required, I am going to get the data, and after getting the data, I'm going to analyze that particular large data set. Okay. So that is how it is going to be stored in whatever the data it is stored in Hadoop MapReduce files. So the framework what you are going to have, that is Hive framework. So this particular framework, what is basically it is also going to provide is, so it is going to provide some of the capabilities of a classical data warehouse. Okay, and it does not exhibit the same performance, especially in terms of query latency. So as we have known that, what do you mean by query latency? So query latency is nothing but what? The time between request and the response. So that latency is nothing but time between the query is asked and the response is coming back from the warehouse. So time between the query and response, asking and responding. So that is what you are asking. You are asking some query, that is, I want the data of this from this particular category, and this particular features should be there for that particular file which I am going to ask. Like that, I'm going to use for the query. Okay. So the latency, how much it will take. So if you are going to have the largest latency, obviously the performance will be low. So now, when you are going to have the latency of that one, if your data is not retrieving very fast, so then what it suggests? It suggests that it is going to have is not constituting a valid solution for online transaction processing. So that's what it is going to have. So if the latency is more, obviously the performance will be less. Okay. So if the latency is less, the performance will be more. Okay. So that's what it tells. So now the major advantage of Hive resides in the ability to scale out. Okay, scale out, since it is based on the Hadoop framework. Okay, so why it is scale out is nothing but what? So as and when the data increases, I can scale it up. Okay, I can add another server, and I can add another server, and those server can be used to store the data. So even the data becomes less, for example, if the data in the future, the data may be less at that time. So when the data is less, obviously what will happen? So I don't want to invest on the server. I will remove that particular server. So it is having the ability to scale out. So since it is based on the Hadoop framework. Okay. So that's what it is going to have. So that is where the Hadoop system will be running on that particular part. Okay. So the next version is MapReduce. Okay, merge. So apart from that one, so it is similar to the MapReduce. It's an extension of MapReduce model, as I told that. So this particular model is an extension of the MapReduce model only. So, but only one thing is the third phase is there. So if you take the MapReduce programming model, you are going to have the two phase. That is, one is map phase, other is the reduce phase. But in this particular model, in this particular extension, it is going to have the third phase, which is called as merge phase. So the third phase which you are going to have in this one, the standard phase, the standard MapReduce horizon. So that will be a merge phase which you are going to have. Okay. So what this particular merge phase is going to do? So if we talk about the merge phase, what that particular merge phase is going to do? Basically, what it is doing is it is allows efficient merging. Okay. So it is going to efficiently merge the data which is already partitioned and sorted by map and reduce model. So as I told you that. So now next, I told that sales of Flipkart, okay, for a particular year. Sales in Flipkart for a particular year. I have taken the example previously. So in particular year. So what that will happen? So I will assign each mapper one. Mapper 1 will be there. Mapper 2 will be there corresponding to each month. So there are 12 months will be there. So 12 mapper I'm going to create. For 12 mappers, I'm going to issue what are the sales happening in each city. Okay, I will calculate with respect to the city. So the mapper will do what? The mapper will calculate, list out the sales in Delhi, the sales in Bangalore, the sales in Chennai. Like that, for each month it is going to list out. So it will map Delhi, Bangalore. So like that, each for each city it is going to map it out. Once it is mapped it out, what it will do in the reduce phase? So that is mapper it is doing. So in the reduce phase, what will happen? The reduction will be done with respect to what? The direction, location. So either it may be a south, it may be a north, it may be a west, or it may be a east. So when it is bifurcated with the south, so it will list out what is the sales in Bangalore for January, what is the sale of Chennai in like that it will list for all the months. Next, after listing all the months, it has to merge. So all these things it is going to merge into a single one. Okay, single file it is going to merge at the end. So all these things, single file it is going to merge. So in that one, it is going to tell you that. So in the south direction, so Bangalore, what is the sale? In Chennai, what is the sale? And if we take the west, west or north, if we take north, so in Delhi, what is the sales is happened? Or in Chandigarh, what is the sales that happen? Or if you take a west, so what is the sales in your Calcutta? What is the sales happened in the Calcutta for that particular year? So it is going to list out, right? So to list out, I have to merge all the things into a single file. Okay. So whatever the partition data are there, so those partition data which are there by the MapReduce, that will be merged together. Okay, that will be merged together and it is going to be displayed in that particular merged fashion. So when you are using the merging, what will happen? So basically when you are using the merging, it basically simplifies the management. Okay, so it basically simplifies the management, okay, of heterogeneous related data set. As I told you that, so it is going to relate with respect to heterogeneous related data set. So if we take about the heterogeneous means what? So different form of data. So it may be a structured, or it may be an unstructured, or it may be a semi-structured. So either it may be a structured, or it may be unstructured, or it may be a semi-structured, which you are going to have. Okay, so it is going to have the provide the abstraction to express the common algebra operators. So algebra operators is nothing but what? And, or, not. So as well as several join algorithms which you are going to have. So relational operators it is going to use. How the relational operator you are going to have. So like greater than, less than. So relational or less than or equal to, greater than or equal to. So and so it is going to provide you the relations, okay, relational operators, as well as after doing that one, I have to join all these things in the merge phase. So that will be done using the join algorithms which you are going to have. So that is about your MapReduce merge. The last one of the extension is your twister. So this is also twister. Twister is also basically a extension of MapReduce model. So now what it allows the creation of iterative execution of MapReduce jobs. So what basically it allows is, it basically allows the iterative action. Okay. So it's going to make, basically allows the creation of iterative execution of MapReduce job. So iterative execution is nothing but what? So it is nothing but parallel execution. So parallel execution of MapReduce jobs is going to do. So now here, so if you are going with respect to normal MapReduce pipeline, so what has to be done first? So first I need to have the mapper. After having the mapper, I'm going to do the mapping, and so it has a repeating. So that particular repeated parallel execution. So the same functionality execution has to be done. So that will be done parallelly. So that is same execution, parallel execution or same whenever the data analysis has to come, it has to be done in data intensive applications. Data intensive operation has to come. The parallelism will come into the picture only. Okay. So with respect to the data. So with respect to the normal MapReduce pipeline, so if you talk with that model, so the model proposed by twister process the following extensions. So whatever you are going to have, so that particular model which you are going to discuss here, so that is going to be happened by the following extensions. First one is what? First one, it is going to configure the map. So you're going to have the mapper. So I have to configure the mapper in such a way that, so how I have to map it. So whether I have to map with the month wise or whether I have to map with the product wise. So I have to configure the map, right? So in the when you are going with the map, configure in the mapper. So I have the mapper function, right? So this we have in the Flipkart sale. So in the example what we have taken, so we are considered with respect to the months, but I can configure that particular mapper in such a way that I can configure with respect to the product also. So what is the product with that particular for whole year? So for a particular product 1 or product 2, product 3. So like that also I can do it, right? So that I have to configure it. Okay, that I have to configure it. Next, what I need to do, I have to reduce the configure the reduce also. So in the reduce function, I am reducing with respect to the product. Okay, so here once the product is done, I can reduce with respect to the month. So in the month, that particular product, if take the month January, so that particular product one is having a sales of this much. So or is the month of February, the product one is having the sale of this one. So like that also I can do it, right? So with respect to the product and January, in the reduce phase, I am going to reduce with respect to the months. So with respect to the mapper, so if I'm going with a city also, I can do it. So in that particular city, what are the sales happened for a particular product? Product 1, product 2, product 3, what are the sales has been happened? So now, while in your configuring your map and reduce, after that one, if the condition holds true, what I need to do? So if the condition holds true, I have to run the MapReduce model. So I have to run the MapReduce model here. After running the MapReduce model, so after running it, so I have to apply the combine operation to get the result. So combine it is nothing but what? It is similar to the merge in your MapReduce merge operation. It's going to be merge operation similar to the merge operation which we have discussed in terms of the MapReduce merge. So after getting your combining the operations to get the result, what we have to do, so whatever the conditions you are going to have, so that condition I have to change. Okay, that condition I have to change. So I have to update the conditions because I told you that so that the conditions keep on changing depending upon the configuration of the map and the configuration of the reduce. So I have to update the condition. So next I am going to have the different condition to be met. Okay, after doing for the different conditions, so what are the result I am going to obtain? So that condition I have to obtain it. First, it will iterate with respect to one condition. So that means when you are reducing your update, the condition is what? First condition I am going to check that bifurcate the product one in terms of the location. So either it may be south or north, or next I will update the product in terms of that particular city. So next I'm going to update with respect to the condition with respect to that particular month. So in January, what is the sale? In February, what is the sale? And in March, what is the sale? That I'm going to update it. So the condition is keep on updating it. So that is where you are going to have that particular process. So besides this particular iterative MapReduce computation. So the same type. So expression it is going to repetition it is going to do, or repetitive operations it is going to perform. So wherever you are going to have the repetitive operations, you are going to have the repetitive operation. So here, whatever the repetitive operations you are going to have, so that has to be computed. So what the twister will provide here. So now compared to your MapReduce model, which we have already discussed. So now the MapReduce, the twister is going to provide you the alternate feature. What are those alternate feature? So the additional feature is first it is ability to map and reduce task. Okay. So it is ability to map and reduce the task to refer to what? To refer to static and in-memory data. Okay, static and in-memory data you're going to have, and the introduction of additional phase called combine run at the end of the MapReduce job. Okay, so it is going to have the aggregation of the output altogether. So it is similar to your merge phase. So it is similar to the merge phase in your MapReduce and merge option. So now you can have the other tools for management of data also in this one. So if you are going to have the in of the other tools, so even you can fix with other tools which is required for the management of the data also. Okay, this is how your MapReduce model is going to work all about. So now, so we have discussed about the different extensions. So what are the extensions we have discussed? There are 5 different extensions, okay, which is working similar to your MapReduce model. What we have discussed, first one is your Hadoop, second is Pig, third one is Hive, so fourth one is MapReduce Merge, fifth one is Twister. Okay, so now if you go with these things, so this will be helpful for you to get a job. Okay, so this is very important for your examination point of view also. So in the next class, we discuss about the different alternatives, okay, which was being used for your alternatives which are there. So it should have the alternatives to MapReduce technique. What are the different alternatives which we are going to have